Ladies and gentlemen, we would like to restart the meeting. I'm sorry that you are just back from lunch, so probably you would be finding more interesting spending the time in a nap. Okay, we will resume. My name is Daniele Bozzolo. I'm currently the technical advisor for the Italian Association of Railway Manufacturer. I mean, it's a subset of UNIFE. And I'm also holding the position of ICTC9 chair. ICTC9 is the international standardization organization that prepares standards worldwide, and the TC9 is in charge of all the technical standards for the electrical, electronic, electrotechnical standards for railways. So it's tightly connected, interconnected with TC9X in Europe. Thank you for your attention. I would like to get started because we don't have much time. We have already, between brackets, eroded the time that we have of 20 minutes. So I will have to be very strict on the timing in order to be able to finish at least keeping the same delay 20 minutes after the timing that we have on our agenda. We can start with the first presentation, that is building the future of railway control command systems at the European level. And we have with us from Eurail FP2, Bettina Dosch. I hope I pronounced correctly the name.
We have a problem with Bettina.
Bettina seems not. And what about Cedric?
No Cedric, but also
Bettina.
Okay, Bettina seems not connected.
Now we can shift to...
So we can go to the next one. Okay, we can go with European digital instructions.
One spoke.
It's Vannes Pope. Is he?
Yeah, it's me.
Okay.
I'm here.
Thank you. I again repeat, if you can be able to stay in the 15 minutes given. Sorry, but
okay,
it's a constraint that we all have. We all share it. Okay, please, can you share your screen? So,
yeah, please tell me if you can see it.
yes, perfect. Thank you. You can start.
Good afternoon, everybody. My name is Wannes Poppe, and I work for Infrabel as an external rules specialist, where I design and adapt regulations related to operational instructions, such as European instructions and national instructions.
Sorry, can you hear well?
I hear you well, yeah. Do you hear me?
Some are not hearing you very well. I don't know, is there anything that we can do?
I can hear you.
It could be a little bit louder, but anyway, it's okay to understand.
Is it okay? It's just the microphone of my
Okay,
laptop.
please continue. Sorry.
I'm sorry. Maybe if I speak a little bit louder,
Yes, that would be great. Thanks.
it will work. Aside from this, from my job at Infrabel, the Belgium's IM, I work as a coordinator of the UIC Sfera Digital Instructions Technical Subgroup. And it's with this subgroup I come forward to this presentation today. So first, about the European instructions, which are defined by TSI OPE and are prescriptive messages actually to be used in degrade situations. For instance, if there's a failure of a signal or some restrictions on the line. And these instructions are currently mainly designed for verbal and paper-based communication between signaler and train driver. And in the TSI-OPE, they are harmonized. The use of this European instructions is harmonized with the content of the European instruction and the format. And although it's mentioned that it's possible or allowed to digitally transmit a European instruction, it's not managed by TSI-OPE how to do so. So this is a problem on harmonization. Many IMs in Europe have started to develop applications to be able to transmit European instructions digitally as digital instructions. But the fact that everybody is doing this independently has as a consequence the non-interoperable characteristic of the systems. Because of the fact that this FERA protocol, which was already present for DAS, has already a framework for digital communication. Many of the participants of the FERA protocol have started with a new project, the DI project, to be able to design the protocol for an harmonized transmission of digital instructions. So about the protocol, the FERA protocol, which the latest edition number 2 was published in 2022, had one main application, the DAS driver advisory systems. And this application is currently in use and in deployment by multiple IMs and RUs. I think it's a quite stable application of a quite stable protocol at the moment, with the latest update of appendices being early this year, beginning of this year. Now, at the end of this year, planned for November, we will publish edition number 3. Currently, we are resolving the comments of the latest revision cycle. And we will try to publish in November, edition number 3. And with this edition number 3, we changed the scope of the protocol from one main application to multiple applications related to train operation data exchange with onboarded devices. And we also changed the title of the protocol. And to have said it all, this FERA stands for Smart Communications for Efficient Rail Activities. If we take a look at the train operation communication, that's we can divide it, we can scale it up on a scale of safety criticality of the communication. And here on this slide, I try to visualize how the FERA protocol has a suitable application, a suitable function for many of different kinds of train operation communications. So if we start with operational information, we define this as operational, defines not the definition, but we can say that this is communication which is used in normal operations. It has no direct link to the safety of the operations, and it's no direct link to the journey of the train. It's just messages to be able to communicate between driver and signaler. And one of the main advantages to do this digitally is that you can translate the message to the language, which is the mother tongue or fairly understandable by the driver or the signaler. For the FERA protocol, we call this free text communication because you can put any text you want. Whether it's predefined by regulations or whether it's just free text as a message, as a text message. And we have this as a function in the edition number 3 protocol of FERA. Then you have the traffic management information, which is information which is structured around the timetable of the train and has a direct link with the journey of the train. It's still normal operations because it's operation about where and when the train will run to. It's no direct impact link to the safety operations. This is the already known driver advisory system, and it's already, as I said earlier, it's already in a far stage of development in the protocol. The main topic of today is the digital instructions, which we categorize as degraded situation communication. It's the European instructions or the national instructions, which are used to give an obligation to the driver, to give a restriction to the driver or an authorization, and has a direct link on the safety of operations, of train operations. It's mostly formal communication with formal communication procedures and prescriptions, and does a higher safety criticism than FTCN does. Which is not in the scope of the Sphere protocol is the emergency situation communication, because the fact that this has a lot of other requirements, like it has to be without latency. And you have other systems like GSMR and FRMCS to cope with emergency communications. Each of those functions in the Sphere protocol has its own goals and benefits. For the DAS system, the DAS function, the main goals are to increase time efficiency, to be able to tell to the driver how to drive time efficient, but also energy efficient, to reduce the energy consumption of the train by telling the driver that if he drives a little bit slower, he will arrive at a green signal, at a signal which is able to pass instead of we will have to stop for instance. For digital instructions, the most important goal is to ensure safe communication. To be able to communicate a European instruction or a national instruction in a safe way without errors. Because today, in a verbal communication, it's always possible to have misunderstood something or to have a faulty readback. And the main goal is to eliminate those kind of errors. Another goal, another benefit, I should say, is that you will decrease the time loss for each instruction if you transmit it digitally, or this is the aim. And we will provide clear and precise, unambiguous instructions to the driver in a uniform way. And this is from the user's perspective. Because of the digital interface, it's possible to have a driver with one interface, which is uniform for his operations, for his RU, no matter which IM he or which region he's driving. Which will also benefit the safety operation of the driver. For free text communication, it's the multilingual aspect that really is a benefit for this function, and also easy communication, to have an easy way of communication between driver and signaler. I would just like to give a quick high-level system overview to show where the Sphere protocol is situated in the communication between IM and RU, and which systems are included. So an IM is free to develop any business tool he needs for his signalers, like a traffic management system or a digital instruction tool. Or a message tool. And on the other side of the communication, you have the onboard devices, and there the RU is free to use any application he needs or for his drivers. He can have one or multiple applications to incorporate any of these Sphere functions. And of course also with the user interface. And then it's the servers and the Sphere protocol that will take care of the communication and the backend to be able to have a uniform and a transparent way of working for either business tool. For the introduction of the digital instruction, so the digitalized European instruction, we invented, we made a life cycle of a digital instruction to be able to have a clear understanding for every partner, every stakeholder of the digital European instructions on how the instruction evolves, and with different lifecycle phases and different lifecycle statuses. With these statuses, we can clearly say from now on, this and this is possible, and this is not possible anymore. One of the main challenges for the harmonization of a digital instruction is to have a life cycle that fits for every IM and mainly for every IM regulations. Because although the European instruction is harmonized, the way the European instruction is used across countries is quite different. In the protocol, we provide use cases and activity diagrams to be able to outline how the protocol should be implemented in the application. It's also a side note because of the safety courtesy of the digital communication of digital instructions, we add a two-way verification for the device that wants to intervene in the lifecycle of a digital instruction, as to say that wants to update the status of an instruction. It's possible for multiple devices to connect and to view the instruction, but it's only possible for one device, and this should be the driver of the train, to be able to intervene in the life cycle of the instruction. And for this, we propose a two-way verification of as an authentication of the driver. But this way of working is also a challenging point for the future, because not every IM or RU needs.
You have another minute.
Needs
Thank you.
Two-way verification. To show a short scenario of the communication of a digital instruction and also a European instruction in an analog way, there you can see that first the signaler will compose and finalize the instruction, which is for analog and digital is the same. But then from the communication upon until the confirmation of the instruction, where today you have to have a real communication with the driver and the signal, we have to have a physical moment, whether it's on the telephone or whether it's on the platform, to communicate the instruction. You can, in the digitalized instruction, you're able to publish the instruction, and then the driver can retrieve it at the moment he fits best. And also, as I said before, the visualization on the driver side can be uniform, no matter which signaler sends the instruction.
Vanessa, I'm sorry, but you're already out of the 15 minutes. Can you please make a conclusion if you can? Thanks.
Okay, so this slide is only to show the way we propose to have a uniform visualization. We propose to use XSLT, which is already a known standard to transform digital languages. I will just leave it with this explanation. And then we have, as I said before, we have some challenges at the moment. We have so the different implementations across IMs and RUs. And we have a different kind of authentication of devices, being the driver's device. We have national instructions which are even more diverse than the application of the European instruction. And we have the need for a one-size-fits-all life cycle of an instruction. And we hope to have a harmonized vision. I'll leave it with this. Thank you very much for the platform.
Thank you, Vanessa. Thank you. Oh, we have...
Good day, good day. Hello, here's Jens.
Okay.
Can you hear me?
Yes.
This is good.
Please
Hello
go ahead.
to everybody.
Thank you.
Do I have the floor? Can I start? And can I share the screen?
Yes, you can start, and if you you can also share your video.
And I will do the screen sharing now, but by the way, it does not, it is now, okay. Full screen, give me a window. So, and now you should normally see something, and now you should even see a full
Yes, we can
picture.
see
Is
it.
that
Thank
correct?
you.
That is very good. Hello, hello, good day. And hola, Madrid. We are here today for DAC. Many thanks for the invitation. This is you wanted to have an information about DAC deployment plan, which is not necessarily
Sorry,
something
can you put it in the presentation mode?
in the presentation mode. In this one?
Yeah, in the presentation, so we can see the full screen.
Yeah, in the present, but I have it in the full screen.
We don't see the full screen.
You don't see the full screen. Okie dokie. And I will try again. Sorry, because this year I could not check before. Full screen. And is that now the full screen that you can see here?
Yeah, actually, okay. Now it's okay. Don't move from there.
It's okay. Okay,
Thank you.
Perfect. Many thanks.
Thank you.
Again, hello. This is now not necessarily about Senelec and standardization. It is, but only in a later stage. But you wanted to have an information. Can you see now the page with my photo on it?
Yes, thank you.
Yeah, that's good. So at least the technology is working. My name is Jens Engelmann. I'm based in Germany, but I am in fact here the European. I have a history of Deutsche Bahn and then a longer time ERA, European Union Agency for Railways in Valenciennes, European Railway Agency, and I served there as a head of unit, and we have built up together the preparation and the agency for the fourth railway package. You remember maybe what happened down in 2018. Then I founded my own company, which is called Reliable Game, and we are doing consulting and technology. And within this, and here this is explanation why you have me here today, I am since autumn 2020 the co-program manager of this, what we call European DAC delivery program. You wanted to know about deployment, delivery, deployment, that's it, yeah? And this is all enshrined and enabled by the Europe's Rail joint undertaking. We had this morning Nicolas Fouriot, yeah, and Europe's Rail, a former Shifter Rail, is well known to you. And co-program manager means that we are two. The other one is the CTO of the Austrian Railways, ÖBB, Mark Topal, who is sitting in Vienna. So, and there is a bunch of people working in this, and I will come to that. So we normally look like this here. You see Europe's Rail layout, yeah, and if you see something like green and dark blue, it looks very much like DAC. And the question here is, why do we do digital automatic coupling with all these elements, you know, the coupling, the digital, and so on? Because, you know, the rail freight there outside, it is still in the 19th century somewhere with all the processes in manual. It takes ages. The processes are slow. Everything is done by humans. That doesn't mean that humans are bad, but you can imagine the productivity. And then you have everything still paper-based. Of course, there's IT, but not at the train itself so much. You have still paper information on it and so on. And on the other hand, you don't have enough capacity in the network to accommodate higher flows of volume if you don't have at least a basis for something like a moving block operation. Okay. Now, based on that, the proposal, and I think you have heard that already since a certain time, this is also why the picture is a little bit small here. You see on the right side down a digital automatic coupler in the current version. This is nothing than a Scharfenberg coupler. Scharfenberg coupler is not the most recent invention. It's 1917, I think, right? But the e-coupler on top, that's new. All the digital stuff, all the electronics, the communication, the data system, of course, that is the new one here. And what does it help for? you can do a lot of use cases with that. It's not only the coupling, it's the automated uncoupling, remote or from the wagon, push button, whatever. You have the automated brake test that saves you already 1.5 hours normally for train departure because no one has to walk around the train anymore. You have finally the basis for further digitization as the information of on loads, or you have the possibility to fit sensors for condition-based maintenance. You have the basis for the automatic wagon inspection if you combine that and blend it with information from video gates, for example, and so on. This is all things that you can't do today because there's just metal. Okay, and then this means it's more than a coupler. It's an enabler for numerous applications, and for what we call full digital freight train operations. At least this is the objective. Then you have some mechanical stuff like heavier trains and so on can be a little bit longer because the coupler is more stronger and so on. But I think generally this is quite evident what you can do with such a system. Now, in short, that means you can now, the benefits, very important, and still we are not yet at standards. We are still on the top level here. Increase capacity, increase productivity, increase the quality. Then we have certainly the aspect of further improved workers' safety. That means there are no buffers anymore. There is no burn room. There is just, space, and people don't need to go in between trains. And then you have certainly in the order of money that we are talking about here, you have something like 10 million plus 20 million, maybe something like employment in Europe for retrofitting and for the components. And then you have certainly still, even if this is at the moment not the big fashion anymore, but you still have a contribution to the EU Green Deal because we all work in rail because we want to make that economically, environmentally more friendly. Okay, so this overall, these are things that are quantified in the cost-benefit analysis. And now to the question, if you want to deploy it, how do you do that? And we set some preconditions, and we said we cannot deploy something on a system which consists of several 100,000 wagons, freight wagons, and of 10 to 15,000 locomotives all over Europe if it doesn't work properly. And if there are not the other preconditions met. And what are they? Single European DAC system. And here we come to standards, because that means that we cannot allow any dialects also from this technology. This needs to be one, so easy and so uniform as today the screw coupler. Proven technology means we need to make sure that this is absolutely working before we roll it out, because we need to avoid this green banana thing. If the rail freight breaks down after installation of our components, or every second train cannot operate, you can imagine that this is not the solution for rail freight then. Same for the operational functionality. We imagine that will happen, but we need also the proof before that really all those benefits are reaped and that we didn't make a mistake. Available adequate funding. That is one of the biggest discussions you can imagine, because we are talking here about a volume of something between 10 to 20 billion euros. And this doesn't come from the rail freight business itself, because these companies are just too poor with the low margins in this market. You can imagine that means we talk about public support and how difficult that is in those times. You can imagine, but maybe we will find a solution for that as well. Simple authorization processes. Imagine you bring all these wagons for a reauthorization with the documentation at the desk of an ERA in Valenciennes or of national safety agencies. I think then our deployment would be over in 2060 or something, because no one can stamp all and check all these documents in such a time. By the way, also you are coming with ETCS and then FRMCS and what God knows, retrofit and other projects. That means that there need to be mass retrofit processes, and ERA and us are working on that. And then we need a sound migration plan, because we have an incredible big brown field of existing assets. And that leads us to the working structure. If you want to deploy something, we would recommend to do something similar than this here. On the left side in this A area, you have the Europe's Rail flagship project 5, which is called the Transformer. On the left side, you have these 85 million euros for developing exactly this technology. Yeah, this is the basis. What we want to deploy is in the order of around 100 million. Then you have in the middle all the brownfield management. On top in the B area, there I am sitting here, and we are trying to manage all the C, D, E, and F areas, which are then the analysis of the fleet, and how many workshops do we have, and what do we have to do on IT systems and infrastructure. You can imagine that is quite a bunch, right? And the D is then about getting the money on board and then preparing procurements and make things all easier and so on. And E is, I just said it, working together with the European institutions so closely that the authorization provisions are easy and fulfillable, and then certainly that the TSIs later on are also properly made. And that leads then on the right side, there you are, Senelec and the others, European standardization organizations, because then you, in the end, will contribute with the standards supporting those TSIs. And this is all the machine that you have to draw up more or less if you want to retrofit a bigger system. And then there is something like Pioneer Trains below. I will come back to that immediately. And I don't go into the details of Europe's rail system pillar, but I think you are familiar with that. Here also technical harmonization, one set of operational procedures and not many ways of using one technology. This is simple, but in the end it's essential to be done. And here's our plan. A good plan is always simple. We hope that it doesn't look too complicated. On the left side, you have the gray areas, which is this A to F tech development. Yeah. Then you have the BCD. This is more or less now the person speaking to you, managing all that, the planning overall. Framework conditions development, that means CBA and the funding provisions and so on, needs to be done in parallel until we come maybe one day to a point P, which we call the DAC legal package, where you have all the TSIs, where you have a management entity, where you have the funding instruments, where you have the standards in place and so on. And then you have on the right side the green hope that there will be the big deployment. And in between, and this is exactly now the phase where we are in here, this is the next important big thing. This is what we call the Pioneer Trains. This is to eliminate, after the technology development, the green banana effect, and that we can, in a restricted number of trains, but in commercial operation, do this all over Europe and test it and see it and check it by heart. And if this is all good, and if we have then eliminated all the flaws, then we will write the final TSIs, then we will write the final standards, and then it can go for production. Manufacturing, I mean supply, right? And here this is already under preparation. There's a grant agreement from CEF underway with a handful of European trains in a number of up to 10 European countries for operating those Pioneer Trains. It's not yet, the ink is not dry, but it should be dry on the 31st of October, so that we then can start this yellow phase, and we can swear you this will be the most interesting phase when we come from R&I development results down to a commercial operation. And this is this project we were talking about, the Transformer, the Europe's Rail. I go very quickly into this, so notice even 95, it's not 85 million euros, where all this is developed with 76 European partners. You have heard about that. And they have done exactly things like the coupler, the electric coupler. They have a train test lab so that they can do something before it goes somewhere out on track. Early testing. They have come up with the operational procedures with the one size, and then they are responsible for achieving the interoperability between different suppliers. And part of there will be also demo trains, which is the pre-version of a Pioneer Train, but it's not yet in commercial operation. And there you will see these things the first time running. And if you are eager to look at it, go to Berlin, Spandau in this train test lab. We can always organize visits for you, because then you see, at least at the moment, the first things operating there, and you can push a button and make an automatic brake test by yourself. And what is now the outlook for the next 2 years? In short, I mean, I could also skip this page and say they need to deliver now what we call the DAC basic package. Is a slightly restricted number of functionalities, brake test, coupling and uncoupling, and the wagon composition and so on, and basics of train integrity. And this is something that we want to roll out, and they need to make that ready in 26 so that then the Pioneer Trains can do something about that and use it in 27. I hope that I kept my time, but this would be
You have been perfect.
presentation.
Thank you.
It's okay?
Thank you very much. Very interesting presentation.
Thank you, and hopefully this was a little bit understanding. I don't know if we have time for questions or if there are any questions, but I certainly
We will be
hopefully
trying to have
answer
the questions at the end of the panel. If you can stay
Okey-doke.
connected. Thank you
I will
for
do.
your presentation.
Thank you very much for your interest.
Thank you.
very much.
So now we move on to the next one. Bettina is connected? Is she? No. So we move on to Peter Grosch?
Yes.
Okay. Peter, hi.
Hi. I was actually good to see you. Thanks for
Good to
having me.
see you. Okay, perfect. You can get started then. Thank you.
I can get started. So happy to be here. Thanks for having me. I also try to be within my 10 minutes. Let's see. I hope that it works like I expected to. Did you see the screen changing?
Yes, it's working.
Great. Okay, good. Then, because now I don't see the original screen from the conference. So, yeah. Hi, my name is Peter Groschke. Currently chair for ETSI Technical Committee Railway Telecommunications. I'm very happy that this is, so to say, sponsored, supported by UIC and certainly ETSI. Very happy to be there. I've been in telecommunications with major operators and also smaller companies since 30 years almost by now, starting in '97. And now part of the FMCS architecture team at Deutsche Bahn, and as I said, the chair of ETSI TCRT. Our goal is certainly to provide world-class standards, as it's called, and I don't want to read through this slide, as this is more the overview of what we do. Specifically, ETSI has been crucial for GSMR, certainly, and out of GSMR now comes the next generation, the future, let's do it like this, the future railway mobile communication system. And we have just had 2 talks about systems that will rely on telecommunication in one way or the other, and we do hope that this 5G-based system is actually the way to go. It all started out back, even the first, let's say, thoughts about it started in 2012. And we have a number of studies done first on interworking with the current system, because both of them will work together, parallel, for some time in order to allow interoperability when different countries and different tracks are actually going to turn into FIMCS tracks one after the other. That's no big bang, but rather a slow migration that's planned. Or not so slow, actually, in railway terms. We have a standardization request, a mandate. We are currently working on that, and we are preparing for the so-called phase 1. I'll come to that in a moment. We have the work items established, so we have a very good view on what needs to be done. And as ETSI, we are working together in a, ecosystem that I tried to draw up on this slide, where we work very, very strongly together with UIC. UIC is acting as a member, but also delivering FIMCS version 2, a set of standards as a basis. Out of that, we form the more precise specifications, which are then used, for instance, and that is crucial for us within the next, let's say, 24 months, Morane 2. So this is the program where actually the FIMCS will be tried and tested and improved, I hope, due to feedback loops that we will establish. At the same time, UIC is a member of the 3GPP, and as a whole, FIMCS is built on the common, let's say, common 5G network. We do have special frequencies, yes. We do use the same voice over IP settings, and we use what's called mission critical systems, which are also done, prepared by the 3GPP. So there's a feedback loop. So once we see that there are gaps, we talk via the UIC with the 3GPP and try to get the railway perspective into the standards so that we can really deliver in the end a very precise, standards-based, rather open system that hopefully drives then the railway telecommunication for the next, let's say, couple of years. GSMR is quite a success story, I believe. FRMCS delivers the whole thing, the whole shebang. And the standards that we are talking about and for which we are mandated, they cover them. So it all starts with an end-to-end architecture, 103764, and then we start on counting. Because of the size of the project, the 103765 was actually broken up into pieces, covering on the onboard side the so-called TOBA, the train onboard architecture. It covers the radio capabilities, it covers frequency aspects, and with that we come to the trackside part. There's a trackside gateway for which there is a definition for a trackside application interface that mirrors the onboard application interface, which allows the attachment of various applications. We are open, whatever comes is okay with us, but which covers the connectivity to the FRMCS ecosystem. This sits on top of the service stratum, as we call it, which is basically IMS features, let's call it, and MCX, and certainly on top of a robust, well-tested network based on 5G, which is already running quite well, and certainly fixed part of the network. Also in scope is the interworking of the FRMCS with the GSMR. That is what we're here for. Standardizing something large like this is certainly quite a task, because everything has to fit together. So everything's interconnected. There are cross-references and references to UIC standards. So this is quite a feat, I must say. But currently we are at the end of what's called phase 1. So we have the first iteration of standards where we still identified a number of gaps, but already have a rather solid system that can now be really tested. So what is the state of the standardization, which is the title of this little talk? That is here in my timeline. We are currently here, beginning of October, and in summer we have delivered the first batch of standards, which are now under review by national standardization bodies. Please keep with us and keep our fingers crossed that nothing happens in terms of larger errors will be discovered or anything. We are quite certain that this is not the case. And with that, we will have latest by the end of the year, the first, let's say, complete edition, which by ETSI standards has then the numbering 1.1.1. So the first one is like the major revision, minor revision, and the first minor, so to say, revision. Out of our standards already, we have been able to publish them on the public site of ETSI as a 1.00. And so these standards are available to Murane 2, a good part of 9 months before the actual first deliveries. And the idea is that with the progress of Murane 2, we will learn from their results and from the lab tests, so there will be feedback to us, and we keep on working here in that blue bar on the standards, trying to improve them and learn from what's actually going on. So here's a field test, which is probably just telling us that the lab tests work nicely, but we are open for any surprises. And the goal is that by the end of 2027 and in time for the TSI 27, we will have the improved, maybe corrected, annotated set of standards. I don't know whether or not that will be a 1.2.1, but let's see for that. And certainly we are aligned, this is why it's here, with UIC standardization going on. And here we are currently in the version 2.1. The goal certainly is to have here around the preliminary ready version going into the final, let's say, testing in the field test. And then the V3, also called the first edition, that will be first edition. For me always sounds like we have then leather-bound books, and I'm very much looking forward to those being the gold standard for FIMCS. So to not bore you and to stay within time, very short summary. FIMCS is already built on a strong set of standards. We really work together. ETSI members, or ETSI is built up by the RUs, by IMs, and certainly the telecommunication industry supporting us. So we are in very close contact and trying to get the best out of that. We are supported by the EU, for which we are very thankful. And working together productively will bring us towards the technical specification for interoperability, or TSI, and that will be the foundation. And I'm very much looking forward going from Poland to Portugal, from Sweden to Sardinia. Okay, that's an island, with one train and one set of telecommunication infrastructure that will work seamlessly over the borders and hopefully very much at high speed. That's what we are looking for in Morane too. And with that, a big thank you for being here, and I'm certainly open for questions.
Thank you, Peter. Excellent presentation, very, very clear. We will try to answer to some questions at the end of the panel. Okay?
Yep.
Please stay connected then.
Happy to.
Thank you.
Yeah.
Is Bettina online? No. Okay. So we try with Adélie Busson from Alstom. Oh, you're here?
Should I go live?
No, please, come here. No. I was, oh yes, you're right, you're not online, sorry. It's the fourth.
How do you want it?
You can open the presentation here, so you can sit there.
I can switch it?
Yes, you have the,
Ready.
no, yes, but with that one you can move the presentation on back and forth.
Tomorrow I need a substitute.
Me too.
Yeah, hello. I'm Adélie Busson. I've been a system engineer at Alstom for almost 5 years now, working on remote driving topics, and more than actually 10 years in the rail industry. Thank you. And I'm here today to share with you our experience with remote driving prototypes. So the first remote driving prototype was done in 2018 with a locomotive train, a Prima 2, which was moved in the north of France in Valenciennes. And it was controlled from a remote desk and a remote driver, which was located near Lyon, more than 500 kilometers from the train. So this first prototype showed the feasibility of remote driving. So with control command function for this locomotive, video replication with a video stream from cameras which were embedded in the train to the remote desk, which was actually in Lyon. And all of this through telecommunication network, which was 4G at the time. So the key feedback from this experiment was that the driver was actually able to drive the train remotely. And with technology such as video compression, we were able to optimize the bandwidth and get end-to-end encrypted telecommunication. Next prototype was in 2023. With Arte project. So actually the focus of Arte project was on automatic train operation over ETCS up to driverless, so GOA4. But during this experiment, remote driving, so from a tablet, as you can see, was also experimented for pedestrian driver. In order to investigate possibility for assistance in case of malfunction of the autonomous train. And last experiment was with SBB in 2024. So it was a larger scale experiment with a focus on ergonomics and human factor. So during this experiment, 25 drivers were able to control the train during 45 days and night. So we get quite extensive feedback from this prototype. The main building block were, again, driver environment replication. So we have panoramic embedded cameras to get the video environment of the train. And we added also microphone on board because it was one of the feedback from past prototypes that the audio environment of the cabin was also very important for the remote driver to understand what was happening. Control command with monitoring also from the train. Telecommunication was upgraded to 5G, which is actually working very well in Switzerland. And fail-safe mechanism was implemented to stop the train in case of communication disruption. And ergonomics, again, was the main focus of the project, and the tests have been conducted and evaluated by DLR during the project. So this is how the desk was looking. So I told you about panoramic view. The central screen is where the focus of the driver is, but the left and right screen are also necessary for driver immersion. We also have the monitoring screen, a few physical control, and some of the control are virtual, which enable to have some variability depending on the train which is controlled. So why we think remote driving can be useful? So we have identified two main use cases. The first one is to optimize the operation. Today there is a trend in Europe that people are aging. So the average age of train driver in Germany is 50 years old, for example, but it's actually true almost everywhere in Europe. At the same time, we want to increase the train, passenger, we need to have more operation. So it means that at some point we need to optimize the operation. And we think that remote driving can actually help in that matter by saving and decreasing the time that drivers spend in the yard or in the depot to wait or to walk over the tracks to go and prepare the train. So that's one of the use cases we have identified. And the other use case is actually to manage the degraded operation of GY4, so driverless train. And this is what is in progress with ERGU standardization, actually. So what are the functions to do this remote driving? So first, we need to wake up and prepare the train. This is not new, but it's an enabler. Then we need to be able to remotely control and monitor the train with access to the onboard train control. We need to be able to capture the train environment, so video and audio, as I mentioned. The remote driver need to be able to interact with control command and signaling, so cab radio and ATP, for example, main topics. Since we'll see that after the driver will miss some of his feeling, we may need to compensate those feelings, in particular haptic feedbacks, with driving assistance. Monitor, so telecommunication is obviously one of the major function of the system. It means it needs to have a reliable quality of service for this mission critical operations. And of course, if we have a fleet of with several remote desks and several trains, supervision will be necessary. So for now, the prototype has focused on one remote driver from one desk controlling one train. But we can imagine that to be efficient, one remote driver on one remote desk will need to be able to connect to a train, prepare it, move it maybe to the first platform without passenger, and then switch to the next train, which may or may not be the exact same type, by the way. So this is the concept of remote driving fleet, with, of course, supervision for both the remote operation center, so the desk, and the fleet. So what have we found with all these prototypes? So first key feedback was on the video. It's a major component function of the system. And it's actually quite challenging to have it operating by day in any lighting condition, but also by night. So we need to ensure color representativity. We need the driver, for example, at night, both to be able to see the route in front of him, to see which are the relevant signals to see, but at the same time to well see the lamps and their color, to see the signal expect. The field of view is also a very important topic. So, for example, we need that when the train stops, it's already the case today, but it stops in an area where the signal will be very visible. And we have limited network resources, so all of this needs to be done with low bandwidth, and we need to optimize the image transmission. As I mentioned also, the driver is missing some of his feeling since he's not actually in the train. So he has no haptic feedback for acceleration and braking. Driver also reported that they were missing speed and distance estimation from video. Since we have two eyes normally, it's much more difficult. But one thing which was interesting is that after a few runs, so 2 or 3, we could already see a lot of improvement, so a major improvement for the driver. That's also where we think the driving assistant function will be of help to compensate for those missing feelings. One of the key feedback was also about latency. It's very important, that's the obvious part, to have quite low latency, but the major findings was that we actually need a stable latency, and it's maybe more important than having a very, very low latency. Stable in time and over the operation. It also confirms that audio was really a big improvement to the prototype. Regarding telecommunication, so as I said, a fail-safe mechanism was implemented. So when the communication is cut, basically the train stops. But one of the challenges will be to correctly dimension the network if we want several trains remotely operated in the same area. It's not only managing one train at a time, but in the area, the network must be sufficient. And as a conclusion, this prototype allows to show that the operation is feasible, that a remote driver can manually control a train remotely. We gain some insights on which we can build to define the next requirement for a long-term solution. There are still some technical challenges which were investigated, and one of the major technical challenges will also be homologation. So it's where a new standard could help to define and have a more efficient homologation process. Thank you for your attention.
Thank you, Adeline. Okay, I assume that Bettina is not there again. So it's your turn, Bart.
Good afternoon, everybody.
Maybe try a bit closer. A bit closer to the mic.
Good afternoon.
Okay, thank you.
Okay, so you have the presentation on the screen. I suppose most people already know me from previous conferences. So I skip this one, you can read afterwards. I will start with a more complex one, just to get you all awake and to see the difficult framework we're all working in. So you know highest level directives, then TSI and below standards. The directive level, it's approved by the RISC meeting, Rail Interoperability Safety Committee. They give the input approval to Commission. Commission makes the final document. Of course, directives is not RISC, it's Commission with the European Parliament and Council. So from there, highest level is a directive. Below, a TSI itself doesn't come from a directive. So it's a Commission implementing regulation. Let's go one level below. Then we're on the TSI level. So ERA, the European Union Agency for Railways, is making the TSIs. But they have a lot of representative bodies that are giving input feedback to them. We've seen some of them this morning. So we've got EIM this morning. We have seen also AERRL this morning. So these are the bodies that give advice and give comments and opinions towards ERA on creation of the TSIs. UIC is something special. They sometimes act as a representative body, but they're not really, but sometimes they do, but they're also something as a standardization body, but they are not. So it's somewhere in the middle. I just put them on the line between those acting and giving advice to ERA and those creating standards. It's called an IRS in the case of UIC, which is an International Railway Solution. So ERA creates the TSIs. On those representative bodies, they can create position papers, but also sector declaration we will see later in the field of this topic of presentation. The standards, most of you will know, there is European standard, but there are also the TS we've seen on Etsy, also using TS's technical specification, a lower levels technical report, and I put on the lowest line also the link between Europe, Senelec, and on the other side, IEC, which is the equivalent on a world basis. With then also agreements, if you make something on a Senelec European level, it is offered automatically to IEC, but also something created on IEC level can be adopted and approved on the same time in Europe, and then you got an EN IEC. We've also seen in a slide, I think this morning somewhere, the Koch coordination group of rail, which is then above all those standardization organizations and the interface also with ERA. It's a hard slide, but I don't know how many minutes it took. But continue, another one, this one I gave already 5 times each year, so it's also maybe each of you have seen it. Every RU is operating trains. The trains shall have on all new, renewed and upgraded rolling stock EMSs, so the onboard energy measurement system. It is defined in the Lock and Pass TSI 2018 was the last major revision. We made in 23 a small upgrade on retrofitting, so it's permitted to use existing transformers that were tested before the EN was published. It's permitted to keep them on board as long as you can prove the accuracy between 20% and 120% of the rated current and at rated temperature. So that's the retrofit 23. It refers to the 5463 from 2017. Data from a lot of trains having EMS are sent to a DCS. Each EMS will send to one DCS. Each country offers a DCS. But it can be, Infrabel is member of ERAS, we're 10 countries together. ERAS offers a DCS. So it can be a joint DCS, it doesn't have to be a physical one. But you can have also multiple DCSs. Maybe some still have old EMSs with a DCS from the manufacturer. This is also a DCS. But they don't use then the standard protocol, because otherwise it can go to the standard DCS of a country. That one is defined in the Energy TSI. The protocol itself is the one from José Antonio. It's now a Senelec protocol, but he invented it before it was adopted in Senelec. Why did we need a protocol? Because an interface between 2 TSIs is not permitted. It shall be uniquely defined, and we had to define this then on a request of commission to ERA to Senelec. I'm adding now also a third document here. That was on the previous one already. So the IRS 9930 starts on the ground side, on the DCS, but the biggest function of the IRS 9930 is the ground-ground communication. Data collected on one place can be, so the EMS also had every 1 or 5 minutes has a location, GPS location. So with this location, you know where was the train with that meter on that moment. Based on that location, you just send the data to the correct country. That's the major function of the exchange function inside settlement. Then what we call settlement has 2 functions. It's the validation of the data of the meter, also the estimation of missing data, and then the allocation to the correct consumer. To do that, infrastructure manager gives data to do this. This can come from the request of train runs. So the TAP-TAF messages, train capacity messages on the train runs, but also how much energy is injected in the substations and thus injected in the overhead contact line, and the total injected shall be equal to the total allocated to running trains. So we have validate, estimate, allocate. Then we have kilowatt hours. In this drawing, I put that there is kilowatt hours going to the energy market and to the infrastructure managers. In many countries, it is still infrastructure manager receiving a mandate and acting for the RUs on purchasing the electricity. So in that case, all kilowatt hours go by infrastructure manager and all invoice will come from infrastructure manager. But a lot of countries already have third-party access or free choice of supplier, and then the RU can choose for his fleet a supplier on the market. I have to continue quicker, but it's also a complex slide. Where are we now? So we started early this year, and at 18 July, we now introduced the documents to create a PREN inquiry to CCMC. They exactly respected the 5 weeks. It's actually on the 8 weeks translation to French and German. And on the end of October, let's say early November, the PREN inquiry will start. But in parallel, we have other work groups ongoing. There are 2 work groups with Commission ERA ongoing, one also with ERGU on cybersecurity aspects. That group will also give feedback to the other group that started, both of them a few weeks ago. It's on the revision of the TSI clauses. The TSI clauses started in 2011 when there was no EN published. So it was an appendix on the TSI with the draft of the EN group already made. And what I've done in the next steps is, here we can take out some paragraphs and we can replace with a reference to a standard. But it's starting from, there is no standard available. So maybe we can reduce the size of the TSI, but then maybe we have to adjust clauses in the EN to permit TSI to refer to those clauses in the EN. So we need a coordination. To be able to do this, we need the feedback of ERA by somewhere January. Otherwise, we can't adjust the EN, and ERA will not be able to adjust the TSI. So for that, we want to get feedback somewhere January. Maybe a little bit more on the next steps. Of course, after in February, we will have a meeting twice a week of half a day online. In February, in March, to be ready early April, because then we have to introduce already the FPREN to have a standard ready by the end of the year. And there is a plan of ERA to create also a new version of the TSI by the end of 26. And if we are not ready by then, ERA can't refer to us, and we are again in the lack of coordination between all the levels. What are the main changes we are having in the 5463? So it's the distinction on the EMS itself, the energy management system, and when it's installed on board, we call it a consumption point. That's made more clear. We add a lot of extra requirements, and also in the data protocol, on what do we need for a hybrid train. A hybrid train has the same EMS, but we need to know, is it running on other traction? Is it using diesel or hydrogen? Is it charging or discharging a battery? Because it has an impact on the consumption, and if we want to validate, we need to have that information. Clarifying process, commissioning, maintenance, introducing possibilities to have an integrated EMF. What's that? If you have one device with sensor measuring current or voltage in the same device as the energy calculation function, and also that you're able to test it as an integrated device. Introducing secure protocols. I won't go in detail on that. That will be the presentation of José Antonio tomorrow also. Plus a lot of discussions in cybersecurity. The full panel 4 is on cybersecurity, and there's the one dedicated presentation on impact on a standard. Possibility of direct connection on board. Also again on the cybersecurity aspect, so digital signature, uncompressed payloads mechanism for a batch of sampling, that's also something else. Sampling of a higher frequency, that's a request. From other countries, Trafficwerk already had the possibility to sample location and other parameters every 1-2 seconds. We are enabling that this is possible in the new protocol. And we already prepare maybe that the next edition in 2030X is a joint EN-IEC. So the protocol will be the same in the 50463 in Europe and the 62888 in the world. Shortly on this one, ERA is having an additional study 3. Aim is to see How is all this framework implemented in Europe? Are all trains having EMSs? Are they sending data to the DCS? Have each country a settlement system? Are they using the data coming from the EMS? Or are there some blocking national requirements, as we heard this morning, that are preventing this? Also, this study is for this year. In October, they should be ready. Then it goes to the representative bodies. And in December, there will likely be a workshop where the conclusions will be presented to the sector. Also on the additional study 02, which is on do we need 4 traction systems in Europe, or can we go to less traction systems? That's the additional study 02. I'm in favor of keeping the other ones, but that's maybe for a coffee break or the dinner as a discussion. Let's go on. And then the on-ground handling, I said before, it's the 9930. Using it was agreed by all sector organizations, so the representative bodies, in a sector declaration. So it's the framework for exchanging the data on ground. It's available for free on the UIC webshop, and also the appendages that can have more frequent updates or on that UIC webshop. Also, the presentation of Wannes earlier, the 9940, is freely available on that webshop, including the annexes or attachments. As the TSI and the EN will have an upgrade and new versions in 27, we're discussing in the group next week if we should not also publish an edition 2 by the end of 27. Last slide. I think we're on time still, moderator.
Yes, yes,
Okay, good. Okay, we're gaining time. A little bit more coffee break, 1-2 minutes. No joking on it, because otherwise we're losing time again.
Right.
So, October 25, next week, we have a workshop in Paris. You can still register. You have to do it maybe now. You can scan the QR code on the screens. But you can also attend online, because maybe going to Paris next week is a bit too quickly. So it's on the traction energy settlement, and it's also dedicated on cross-acceptance of the EMS verification. Is the work done from the notified bodies? Do we get the correct information? Is the binding working correctly? Is there a maintenance plan made? Is this given to entities in charge of maintenance? Is this respected? So these questions we are attacking on the workshop next week. So it's a more complex workshop than just the dissemination. We want to also discuss more difficult topics. November is the start of the 3-month inquiry of the PREN. So if you're a Senelec expert, you can give your comments to the group. I will present also in November on an ERAS webinar the changes in the PREN. So if you want an introduction before reading it, it's also possible to consult the ERAS website and then register to that workshop. December is the approval of the EN. No, of the that's next year. I'm not shifting. This year is the publication of the additional study, and December or early January the input of ERA to the PREN. End of the year is both documents. Then there is a risk meeting in February, but it's impossible for Commission to have the Commission implement the regulation in February. So earliest time is June to have the TSI approved. And then maybe end of next year the next edition of the 9930. This is the last slide. This was where the 10 countries in a partnership having one joint solution on how to do this together. So that's ERAS, with also a similar schema on how the data is coming from the trains to DCS to exchange to settlement and to invoices. And that's the presentation.
Okay. Thank you. Thank you. Very nice, very interesting. So now we move on to the next one, Luis Alonso from SNCF. Yeah. Perfect.
So today I will explain you how we would like to use the parking faces automation at SNCF for high-speed trains. So first of all, I'm Luis Alonso. I'm an energy efficiency engineer. I work in SNCF Voyageurs, the national company of France, at the Rolling Stock Engineering Center. So I get my PhD in electrical engineering in 2002 on energy consumption model for electric trains. Since 2022, I have been working at SNCF for on battery trains, ultra lightweight regional trains, and the eco-salary mode of different trains. So first of all, why we keep always our train on? Maybe it's a specific case of France, but they are nearly always on. So when we have steam engines, it was quite obvious. We need between 3 and 5 hours to fire up a locomotive, so it was better just to keep it on. And also because we have a big mechanical fatigue in the boiler with the hot cold cycles. When we get the diesel engines, nearly all the problems have gone, but especially in winter we have difficulties to start up the engines. So in winter especially we kept always the diesel trains at idle. With electric engines, we have different problems. The problem is mainly the humidity in the train. When it's cold and humid, the humidity gets inside the electronics and the electromechanic parts of the train. And when we like just to power it on again, we have big surprises in flash consequences. And also we have problems with the auxiliary batteries of the trains. It's the same case for the diesel engines. When we stop for 2 or 3 days, then we are not able to switch on again easily the train. And finally, with high-speed trains, we have another constraints. So first thing is the customer service. We have a bar that is always in the train. And here in France, we have a specificity that is only in Paris we can get off the food. Otherwise, if the train is outside Paris, there is always food inside. So we have to keep the fridges always on. So we have to keep the train always on. And also, the other problem is that we have longer service times. The train runs more time during the day, so we have less time to make the maintenance. So we need to have the train on just to go to maintenance, just to make the cleaning. So that's why actually we have always our trains on. So that has an impact in the energy consumption. So we can see that from 2015 up to 2025, we have already reduced by 10% the energy consumption, having more and more trains running. But we have to note that nowadays, always we have between 10 and 20% of the consumed energy is during parking phases. So we are going to attack this consumption because it's the less useless consumption. And we think that they're easier to reduce. So actually what we do, we have actually what we call the holding mode. The holding mode at the train station was useful because when the train arrives and we have to change the direction of the train will just hop off. You have to go to the other side of the train he have to walk between 200 to 400 meters. We can be maybe between 5-10 minutes. But the problem is that during this time we have to keep on our train because we need between 10-30 minutes to have to power on the train, all the security systems, for example. But also sometimes we have also passengers inside, and they like to have the HVAC, they like to have the Wi-Fi, the power outlets. So that's why we have a holding mode in our trains. And as we had this mode, we also use it at the depot of the sidings, because the train driver came, he just hop off. The train was always on until the maintenance crews came. And during the maintenance, it was also good to have the train on because we could have the lighting for the light maintenance. We could have also the power socket on for the cleaning of the teams, and also we have the food at the bar, so we could keep the food cold. So around the 2010s, we asked Alstom, can we do something about it? So they make what we call the native eco mode. This mode make that when the train arrives at the depot or the siding, the train driver just goes, and we have a timer that go on between 10 and 30 minutes, and after this time, the eco mode it activates. What is this eco mode? The train is always on. All the security systems, they're always on. But we enlarge the regulation temperature. So in in summer we allow hotter temperatures, and in winter we allow colder temperatures. And we also reduce the lighting level of the train, but it's always compatible with the maintenance. So we have less light, but enough light to make the maintenance. So that was for the new trains. At SNCF Engineering, we said, okay, what we can do with all the generation trains. So we developed a retrofit eco mode that makes the same functions, but we give it a plus, and we restricted the activation areas of this eco mode. Here, for example, we have a map of Paris. The blue dots, those are the train stations where you have TGVs arriving. And there, we don't want to have an eco mode because maybe the train driver is no longer there. So the eco mode just switches on with passengers inside. So we have restrained the activation zone to the red cycles that are normally the sidings or the depots where we make our maintenance. For the performance point of view, we can here see the results. So in gray, we have the old trains. In black, the new trains. So with the dashed line, we see the actual consumption at the standstill with the train on. We can see that this is especially high in winter. And with the solid line, we can see the consumption with the eco mode. So we can see that especially in winter, we have a huge gain in energy savings, and it's especially in this time that we should activate the eco mode. But that is what we are doing, for instance. But what we would like to do in the future is that when the train arrives at the depot or of the siding, the train driver just hop off, and again we have a timing that starts. But during this time, we are going to get off all the food at the depot. We are going to properly shut off all the systems because we just make it too fast. We will generate some default codes on the train, and then we are going to put down the pantograph, and the train will stand still like that. But maybe the most important question that we have is when we have to wake up our train, just to ensure that our train is ready to enter the commercial service. So for that we need a kind of a database aggregator. For one side, we have to have the running timetable of our train, so where and when it's supposed to make the next commercial service. Of course, we have to have the okay from the maintenance saying that the train is okay to run and there is no one longer in the train working on the train. And maybe the other important option is the weather forecast, because if it is extremely cold outside, we have to wake up our train earlier just to give enough time to reach the optimal temperature. So we have all those information, and the database says it's okay. So our train will put up the pantographs, and will give enough time to power it on in the good way, to have the right temperature to enter the commercial service. So in conclusion, we have some benefits, we have some risk to control, and then I will talk about the prospect. So in the benefits sides at SNCF, we can save up to 130 gigawatt hour of energy each year. That is the potential energy savings that we can reach. Also, we have the good point, as it will be automatic, the train will be always prepared to enter in the several commerces in service. We will no longer have any kind of forgottenness and saying, oh, I just forgot to go to switch on the train, or the train driver was late. And yeah, up to some point, we are going to extend the component's lifetime, because as they will be less switched on, their life will be longer. In the risk to control, we have also the same things. Is the impact in the components, because some components will be cycled more times, will be switched on and switched off more times. So other components will have shorter lifetime. Maybe the most important point for us is the safety. Up till now, when we switch on a train, we have always someone in the train, and he could see if there is someone working on the train. When it will be automatic, it will be no one longer in the train. So we have to really be sure that no one is working on the train before just energizing our train. And we have also to optimize our maintenance schedule. We can just not say, okay, the train comes, we will switch it off, because then 1 hour later, someone will switch it on just to make the maintenance. Then 1 hour later, we're going to switch it off. Just for 2 hours later, the clean team can switch it again on. So it's a risk that we have to control, just to optimize. I just say, okay, we are going to switch it off because the maintenance and the cleaning is done, or because we know that it's going to be done in 3, 4, 5 hours. So in prospect, what we have is that our first manual test will be making 2026. So we are going to make this kind of establishment of the train, but just in the manual, just to see the performances of the components, just to see that all the components stands well. This kind of shut on of the train. We have also to test the connection between the ground and the train, just to put up the pantograph in a safety manner for the hacking point of view. Normally we will do that by the end of the year. And we are also thinking about putting this same strategy into regional trains that have less constraints than the high-speed trains. So that was all. Thank you for your attention.
Okay, thank you. Okay, we can move on with the next presentation. That is André Philippe. Thank you.
Hello. When you buy one guy of SNCF, you have a second one for free. So that's why I'm here today. So I will not use the SNCF. Okay, great, thank you. The SNCF cap today. We'll use my cap of Europe's Rail, because I'm involving in this program. Very short presentation. So I'm also in SNCF Voyager, so the rolling stock part of SNCF, working since many years in energy efficiency and decarbonization projects, and so working also in the latest research program like Shift to Rail and now Europe's Rail. So today, one major context for the railway sector is the improving of energy efficiency, especially due to the increasing of the energy cost that we face off since several years. And additionally, we have the big challenges to reduce the carbon footprint and be able to have a carbon neutral railway beyond most of the time 2050, even if some countries are more ambitious to be carbon free before this date. And last but not least, the adaptation to climate change with a lot of heavy rains or high temperature that are quite difficult to manage for the rolling stock especially, but also for the infrastructure as well. So in the Europe's Rail project that you have a short presentation this morning already, so I will avoid you to have it twice, but we have a project named Rail for Us, so focusing on the sustainability of railway, and one work package dedicated to the pre-standardization of the alternative drive trains and on the energy management at system level. So I'm the happy leader of this group of roughly, it's not roughly, in fact, it's just 11 partners, with infrastructure manager, train operators, but also research center, and mainly that's all. But we have also some affiliated entities with universities, especially is involving in this project. This work package is divided in two tasks. First one focusing on the pre-standardization, so on the way to try to suggest recommendation to improve the standardization and the regulation related to the alternative drivetrain, so the battery train, hydrogen train, and so on. So we focus mainly on three interfaces: on the component system for the batteries, for the traction batteries, I mean, for between the train and the infrastructure, like the hydrogen refueling or for the battery charging, and between the train and the operation, for example, for the supervision of the battery fleet. The second task on the smart energy management, we are more focusing here on the energy management functions that we can use on the vehicle and that are supporting the energy efficiency of the train. And last task, more focusing on the optimization of the energy at system level and on to try to have a common circle to compare the alternative drive technologies. So if we look at the energy storage unit, so the battery packs, if you have some visits on some show like in France and so on, you have seen many battery packs, more and more on rail vehicles. In Europe, we'll have around more than 1,000 vehicles equipped with this kind of energy storage system in the near future. So it's a real game changer for the industry. And so we see many different designs. So it's not efficient from cost point of view and also from the design. So we have long discussion between industry and operators to try to have some proposal and preferred solution for these different battery interfaces. So on the high voltage connector especially, we suggest to develop a European standard that is today not available on the plug and socket, because this type of plug is not standardized anymore. So we like to avoid the troubles we had with, for example, the phones. On the low voltage, we have already a standard focusing on the traction, the lithium-ion traction batteries. So we suggest to modify and update this standard with some common test and type to use for this low voltage type. For the cooling, we prefer the quick coupling solution, and for the communication, for the BMS or the battery management system inside the SU, we suggest to use the CAN type, and for the communication between the energy storage system on board and the vehicle, to use the TCN solution. And for the SS parameter, it's a very huge topic that is today not closed, but we are focusing on trying to standardize the data to be exchanged for different purposes, for the ESS monitoring, for the maintenance, but also for the driver information and for other users. So all this work is still ongoing with regular meetings between the experts within the Europe's rail. On the interface between train and infrastructure, I selected the example here for the hydrogen refueling, because today we know that the hydrogen technology is quite expensive, and especially when we build hydrogen station, most of the time the hydrogen station are not able to refuel any kind of hydrogen vehicles. So it's quite a mess, but that's it for the moment. So we agree mainly with the operator on the requirements about the duration of the refueling time to achieve 15 minutes, which is the equivalent to today the diesel train, and also to have a kind of option to reach the 30 minutes for the maximum refueling in case of very important consumption of the fuel. Also some other agreements on the distance between the dispenser and the receptacle, about the type of compressed hydrogen to use, because we have 350 bars, but also we see some example with 700 bars, but more in the Asian project. And one of the main work at that moment is to work on a solution based on the RFID tag that can be used for, we'll say, a smart but simplified refueling solution with a table with the recognition of the vehicle type, and to be able to refuel the train with this based on this table. And to finalize on the task one, with some example about the range calculation, today we identified that there is no standard on the range calculation, and we see many announcements about world record, about range by Steyler, more recently by Great Western Railway. And so today we see that there is no official and standardized method on how to calculate and estimate the range calculation. So everyone can say, my train has 50, 80, 100, and so on. So we made an analysis about the different way we can estimate the range calculation, and our proposal will be to create a standard similar to the WLTP test that has been used for the automotive sector, but applied to the railway industry. And related to this, also to develop a standard for the calculation methods and the definitions of the range calculation, because we see, especially for the battery train, due to the reduced energy capacity on board, the range calculation is a very priority, a really big priority for the operation. About energy management, so we made first state-of-the-art of the kind of energy management function we can find today on the rail vehicle, and so we try to have a standard descriptions, block diagram requirements, and estimate the impact on the standardization and regulation. And today, the outcome of this group is to be able to have a total of 77 requirements on energy management functions that can be used by the rail operator, and also with suggestions to modify standards and regulations. So especially to make the link with the previous presentation this morning, this suggestion will go to the famous STIP file that everyone wants to avoid to read because it's quite complicated. On the energy management, so we also work on how to optimize this energy management function. Here is a short example with the charging process of the battery, because today most of the battery train vehicles have a quite secure charging strategies that have the priority to recharge as much as possible the battery, to be sure that when you use the battery on the non-electrified section, you will have the more energy available on board to run. So we try to analyze more energy efficient solution, and especially to reduce the charging power of the batteries. And so we have been able to reduce from 40 to 8% the number of time with more than 1C, so one time the charging current of the batteries. And so it's good for the thermal losses, the aging, auxiliary consumption, and so on. Regarding optimization of the energy at system level, as I said before, the objective was to develop a common methodologies to compare the different alternative driver technologies. So we established a methodology with different criteria on rolling stock, infrastructure, and operation, but also on energy and CO2, and on the energy storage system. So we define a method with use cases and different scenarios that we are comparing to be able to find the best solution. So basically, as we can see here, we define a use case and a scenario, like for example, a battery train with additional charging infrastructure, or a battery train with a bigger battery. We apply it on a line in the south of France here. And so we compute and simulate the energy consumption of the vehicle. And based on the result obtained on the operation, the vehicle cost, the energy storage system, the infrastructure, and the energy and CO2, we obtain a score, and so we are able to compare the different scenario on the use cases. So the conclusion of this project right now, it's the very interesting and major progress we have with this international collaboration. Regarding alternative drivetrain, we have a lot of exchange between the experts to give and recommend preferred solutions. And so it's good for energy and for cost efficiency, for affordable solution. And so we continue to work on the methodologies to develop all the future of railway system, and to achieve the KPIs on the Europe's rail regarding the battery train, so especially to reach the target of 200 kilometers, which is a quite interesting goal. And that's it for me. I hope the time was
Yeah,
good enough.
perfect on time. Thank you. I'm not sure we should be moving to the last presentation unless Bettina is connected. I call here Antonio Lugara, please. It's your PC.
I am not multitasking. Unfortunately. Well, sometimes in the lab with each group working at the same time, you must be multitasking with dealing with the problem of the student.
Okay, great. Thank you.
Okay,
Antonio, please, you can start.
Thank you.
Thank you.
good afternoon, everybody, and thanks a lot, Mr. Bozzolo, for the kind introduction. As it was introduced, this presentation is dealing with the evolution of the concept of the electric substation, going from the legacy paradigm up to the intelligent substation. First of all, let me introduce myself. I'm Antonio Lugara. I'm a civil and transportation engineer. I deal with the IoT special project in transportation and industrial sector in EMEA. And it is not my first time presenting at the ICT for Railways, and I'm very glad to be here with all of you today. The digital transformation is embracing the entire railway sector overall, and thanks to the availability of data sampling, of data extraction techniques, and data analysis technologies, there is underway an improvement of efficiency and also an increasing of the automation level within the different areas such as operations, infrastructures, signaling and related supply chains. More than ever, right now, there is a mutual contamination between the information technology and the transportation engineering, requiring skills and competencies that transcends from the concept of the classical engineering. During the rest of the presentation, we will discuss about the evolution of the electric substation and which are the capabilities of the new design and the new concept of the intelligent electric substations. Let's say that these infrastructures are crucial to drive the industrial Internet of Things revolution. And during the next chapters, we are going to discuss about the different concepts, so the legacy infrastructure, the digital substation, and the intelligent substation that represent the state of the art. For what concerns the intelligence infrastructure monitoring, we are going to focus the attention on the architectural aspect, the technological stack, and the implementation paradigms. For sure, it's crucial to understand and to focus the seamless integration that there is between IT data and OT data, and this integration is this blending of different data sources, very heterogeneous, is the backbone behind the intelligent substation. And in the last chapter, we will see two use cases related the implementation of thermal analysis, computer vision, and AI applied to convert unstructured data into structured data. Electrification is crucial to drive the industrial Internet of Things revolution, and according to the International Energy Agency, by 2050 there will be more or less 50% of the energy demand satisfied through electricity. This because thanks to the flexibility for production and distribution of electricity, and also because electricity is able to meet and satisfy different constraints coming from the different players that are going to utilize it, such as residential buildings, factories, transportation systems, or data centers, but also is able to meet the requirements related to the distribution energy resources, because the electricity can be produced in different ways. We know carbon, wind, photovoltaic, nuclear, and so on and so forth. But very often within the grid there are distortions because supply and demand are not aligned very often, and this is the reason why we require to drive this industrial revolution a network that is self-capable to set the vital parameters, the state variables of the systems in function of the different boundary conditions that are detected during the operation. One quick question. What is an intelligent substation? How you will describe the prerogatives that are behind an intelligent substation? For sure, we have to start from the connectivity. An intelligent substation is replacing, for what concerns the connectivity, all the copper with the fiber optics, implementing new protocols such as EAC 61850. This means that we are able then to equip the intelligent substation with the protection devices, IP connected devices that can measure in real time all the different subsets and equipment of the substation. This means having an operational awareness of the substation in real time, having a system that is talking each other and communicating from the different nodes of this network is possible to identify the best configuration to have to increase KPI of efficiency and effectiveness. This means, of course, having also data processed in, at a glance and the edge, and this means identifying early warnings in proximity. So, in a nutshell, an intelligent substation is require the satisfaction of all the prerogatives that we just saw. So we are able now to define what is an electrical substation, and here you can find the definition. But I would like to focus the attention with you regarding the maintainability of an intelligent substation. In fact, an intelligent substation cannot avoid to have a very detailed failure mode analysis behind to identify all the different failure modes, and then thanks to the technological backbone to measure in real time the distribution of those values and to understand the adherence between the real values measured and the expected values that should have some range of feasibility. As we said, the implementation of fiber optics and the protocol EAC 61850 could be considered as a condition necessary but not sufficient to realize an intelligent substation. As we can see in this figure, in red, we see the station bus that is interfacing all the most crucial element of the substations, giving them the possibility to send data that are collected and analyzed in real time, and that allow to improve a lot of KPIs that can be clustered into 5 main areas that are safety and security, efficiency, reliability, flexibility, and sustainability. Some examples are, for instance, the implementation of a cybersecurity layer to protect the mission-critical elements, also the standardization of the interfaces, or the enablement of remote analysis in real time. But an intelligent substation is not just the sum of tools, connectivity, and technology. but it requires also standardized processes, tested procedures, and specific guidelines. This is the reason why, in addition to everything we said until now, it's crucial to have asset management procedures that are based on, for instance, in line with the ISO 55000, in order to have the possibility to reduce risks. And when I talk about risk, I mean reducing the exposure to dangerous events, but also mitigating the magnitude of the consequences once the events happened. In this way, applying also these principles, it is possible to improve a lot of KPIs that we can cluster in 5 main areas: productivity, cost optimization, governance, safety, and visibility. We discussed until now about guidelines, goals, expectations, and constraints related to an intelligent substation. But let's now focus the attention on the architectural aspect behind. So we can imagine our intelligent substation made of 3 main domains: the web client, hosted, and edge. Web client is the front end. So it is the layer in which it is possible to visualize what's going on in the substation. It is possible to visualize measure, data, event counters, even reports made with AI techniques, but it is also possible to act countermeasures when required to respond to potential failures or performance degradation. Then we have the hosted layer. The hosted layer could be is the data center part. It could be stored on site or could be on cloud. And in this way, it is possible to evolve from the legacy substation to the intelligent one, because we can add a brain with several IT tools that are, for instance, enterprise asset management, performance management, work order management. So we are adding an intelligent layer to the legacy substation. And in this way, this is basically the kernel, the backbone of the substation, the intelligent substation. The edge is, of course, the proximity aspect in which there are IoT devices and some other elements that now we are going to visualize in a better view into the technological stack. In fact, from a technological perspective, we can have 2 main areas: the intelligence infrastructure monitoring and utilities equipment maintenance system. The first one is related to edge devices. So we have IoT devices, we have thermal cameras, CCTV cameras, we have speaker horns, we have all the devices on the field. On the other end, the utilities equipment includes all the IT stack. So we have there, for instance, field service management, work order management, asset investment planning, ERP, and all these items that are adding an additional layer of knowledge to the substation. Just the holistic view of the 2 main domains can provide the backbone for the intelligent substation. And this means that just through the vertical integration from OT and IT, means digital products, digital enabled services, software, means all the IT stack, blending together these different domains, it is possible to create the conditions to have an intelligent substations. And in this way, it is possible to create a statistically representative data set in which it is possible to apply big data and to calibrate predictive models. Predictive models that can be run according to 2 main approaches: the data-driven approach and the knowledge-based. The knowledge-based is function of failure mode analysis and the analysis in real time of the state variables, identifying the adherence between the expected values and the real measured. The data-driven approach is completely different, is more big data oriented. So we are going through unsupervised models to identify some behaviors that are not engineering on in advance, but that can represent a trigger for potential incipient malfunctions. In the next 2 slides, we are going to see some screenshots, unfortunately not video because Paolo didn't allow to include videos in the presentation, in which we can see how the computer vision, thermal analysis, and AI are utilized to retrofit existing substations and converting unstructured data into structured one. For instance, we can see with one single camera, we can identify up to 10 points of interest in which we can do a thermal analysis in terms of absolute temperature, gradient of the temperature, dynamics of the temperature over the time, and also we can achieve economies of scale and of scope, reutilizing the same cameras for other scope, like enforcing intrusion detections or some other scopes. This is the intelligent substation is basically a decision support system, as a decision support system embedded. In fact, per each asset that could be primary or secondary asset of the substation, we can identify dozens of use cases to detect the health status of the item, and per each use cases we can have dozens of KPIs to be measured. In this case, we just as an example, we are analyzing 3 assets: high voltage transformers, oil field transformers, and the substation automation and communication system. Per each of those, there are dozens of use cases, but here is just an extract to let you understand that the result is basically a DSS system that maintainers can use to take actions data-driven and not just in function of their perceptions or feeling. I should be, I think, more or less on time. So thanks a lot for your attention, and please do not hesitate to contact me if you want to go deeper in one of those aspects, because considering the heterogeneous domain behind an electrical substation, an intelligent electrical substation, summarizing everything in 15 minutes was not really easy, but I hope to have the chance to talk with all of you about some deep dive. Thank you very much for your attention.
Thank you. Thank you, Antonio. Now, under the assumption that the lady Bettina Deutsch is not connected, so we almost got back on time, I would allow one question from the floor. Is there any question for our speakers? One at a time, please. Oh, there is one there. Martin.
Martin Reed. I have a question for...
Hold on a sec. It will be getting your mic.
Okay.
Because probably the people that are online will not be able to hear you properly.
You must come here to
Can you? Okay.
It's for Adele, actually. I have a question. It's a question for Adele. I was interested in the discussion you said about the failure of communication, and then you've got a fail-safe. Could you say a little bit more about that? What is the expectation for how much failure? So if you've got a failure in a communication system for an autonomous driving train, GO4, you need to stop the train. How much time did you consider is a minimal amount of failure that you need to do something, and how soon do you need to act after that failure?
Okay.
Roughly.
No, it's okay. So thank you for this question. And so in the prototype we had, we considered a failure time of 1 second, but it was just a prototype. So first thing is that safety analysis will need to be conducted to take into account the braking distance necessary for the train at maximum speed allowed. So there is a long route to define the actual good value for this communication broken time before fail-safe reaction is triggered. And after the prototype, I don't yet have the answer. What I can say, however, is that with this value in our prototype for the 45 days where the prototype was used, it actually did not happen. So that's why I can say I'm quite optimistic about the fact that the network quality of service today, if we do the work for the safety and the homologation, will enable us to use this feature. So I hope I answered your question.
Thank you for the answer. I would like to take advantage of this second just to thank all the speakers for the quite interesting presentations. And I would close here the panel number 2, and we will be reconvening in 10 minutes as planned. It's your problem now.